Hey, Math 20-2. So this lesson, what we're going to do is start focusing on polygons. And what we're going to be able to do with these polygons is we're going to come up with two formulas. One for figuring out what the angle would be in any polygon connecting two sides. And the other formula is going to be just the total sum of all the angles. So first one says draw 5 equal, not equilateral triangles, raying out from the center of the below polygon. Use the diagram to determine the angle between the sides of the polygon. So what we're going to do is just make a point right in the middle, and then we're going to make triangles that connect from there to there, one there to there, and that'd be one of my polygon or one of my triangles. So I'll draw the rest here. Okay, so you can see that we've drawn 5 triangles near, right? So then part A says, how many triangles did you draw? Well, we drew 5. So in the pentagon, 5 sides, we drew 5 triangles. What is the total sum of all the angles in the above triangles? So if I took, that angle, that one, and did that for every one of these triangles, well, one triangle, the sum of all the angles is 180 degrees. Well, we have 5 triangles, so that's just going to be 5 times 180, which is 900 degrees. So all of the angles involved here, there's 900 degrees. All right, so by subtracting out all the central angles, how could you determine the angles between the sides of the polygon? So we want to figure out, we don't want these angles anymore, so like all our central angles. We want to take those out of the equation. So I know that if you do a circle from one spot all the way around and back to where I started, that's 360 degrees. So if I just subtract, so with I got 900, if I just start with that 900 and subtract 360, so the center out of that, that's going to leave me just the angles around the outside. So that's 540 degrees. Okay, what is the angle between two sides in a regular pentagon? Well, let's just keep up with our logic here. So I know now that 540 degrees is the sum of all the angles around the outside. So like that angle, that angle, that angle, and that angle, right? All together is 540. Well, I don't want all the way around the outside. I just want one of these things. So there's 5 of them, so I just need to go 540 divided by 5, because there's 5 sides, which is 108 degrees. Okay, so this is generally the method that we're going to use, but we're going to turn this into a formula in a minute. But for now, we're just going to use the same idea. And number 2 says, use the above method to determine the angle between the sides of each of the below polygons. So this polygon has 10 sides. Okay, so we're going to do the same thing here. So I know I've got 10 triangles here now, right? Each triangle, all the angles have to add up to 180 degrees. I've got 10 of them, so I'm going to go times 10. So that's going to be 1800 degrees. So that's all my angles, right? Like every angle, like that one, and that one for every triangle. Then all I'm going to do is I don't really care too much about the inside angles, and I know all the inside angles together have to equal up to 360. So I'm going to subtract 360 degrees from that. So I'm left with 1440 degrees. So remember where we're at now? So this is going to be the angle. Shouldn't do that for a minus sign. The angle all the way around the outside. So everything but these central angles. So all the way around the outside. Now if I just want one of these angles, I know that there are 10 of these all the way around. So I just need to divide that by 10. So if I do that, I know that it's 144 degrees. So each one of these must be 144 degrees. Okay, so I'm going to let you guys go ahead and do this one on your own. All right, so what we're going to do for number 3 here now is we're going to actually figure out a formula. So for every one of the ones that we did, all we did was we went 180 times n. And I'm going to write that instead of like times n because the time symbol looks kind of like an x. So I'm just going to write 180n. That was our first step up here, right? That's what we did, 180 times whatever number we chose there. Then step number 2 was we went minus 360. So I'm just going to put that down. So minus 360. And then the last step, again, was just dividing by however many n we had. So last step was just dividing by n. So there you go. That's our formula. Now, this is totally a correct way to write it too, but I'm going to write a little bit simpler, so we only have to put one n in if we're ever plugging it in. And the way I'm going to get there is I'm going to rewrite this expression as 180n over n minus 360 over n. That's what it means. If everything is over n like that, you can rewrite it just like this, right? Okay, so if I do that, the reason why I did that is because now I can cross out those two n's. They cancel with each other. So, because they're in the same term. And what I'm left with is just, this is all equal to 180 minus 360 over n. So now no matter what polygon we use, we just have to put in the number of sides and we're done. We figured out what the angle between the sides are. So if we wanted to use our new formula, determine the angle between two sides of a 30-sided regular object. So that'd be 180 minus 360 divided by 30. If you put that in your calculator, you get, so wait, what do you get? 168 degrees. So it's that easy once we know our formula. All right. Okay, so for number 5, it says each interior angle of a regular convex polygon measures 144 degrees. How many sides does the polygon have? So we're kind of going in reverse, right? So I wrote down our formula that we made. And now this time it's saying that this is all equal to 144 degrees. And we want to know what n is. So we just have to do a little bit of algebra to figure that out. The way that I would do this is I would use a different pen. I'd say, okay, I'm going to add 360 over n to both sides. And the reason why I did that is because it's going to end up with a positive 360 over n on this side. It just makes, you could have done it both ways. So those cancel and they end up with, plus 360 over n. And now what I have is I got to just get rid of that 144. So, wish I had more room here. So I've got 180 is equal to 144 plus 360 over n. Now I'm going to subtract 144 from both sides. Okay, and what I'm left with over here, I'm just going to write this over here to give myself a little bit more room. You've got 36 on the left side of the equation, 180 minus 44, it's 36, and is equal to 360 over n. The next thing I'm going to do is I'm going to multiply both sides of my equation by n, so those cancel. I've got 36n is equal to 360. I'm going to divide both sides by 36. And I'm left with n is equal to 360 divided by 36, which is 10. So it must be 10-sided. So just a little bit of algebra in the end there. So, okay. Number 6 says, using your final formula in 3, determine a different formula that would find the sum, so adding all together, of all angles in a regular polygon. All right, so if we start off with our formula that we made for 1, so remember this formula, remember what it does, is it tells you what one side is, right? So if I want to figure out what the sum, so all my sides, I'm just going to multiply it by how many sides there are. So I'm going to multiply it by n. So this is really our formula as it is, but we usually like to have a little bit cleaner looking. So what I do is I distribute this n to both parts of that equation. And we end up with 180 n, right? Because I multiplied that by n, minus 360 n over n. And this time those n's cancel, and our equation is just 180 n minus 360. So that's our formula for the sum of all the angles. All right, so last one here says using the formula from 6, so this formula, determine the sum of angles of each of the below objects. Verify with a protractor. Does the formula work for all objects or just regular shaped objects? Okay, so what I'd like you to do is you guys can actually go ahead and do that. What you're going to have to do, all you really need to do is, we know everything in this formula except for n, right? N's the one that we don't that can change up. So all you got to do is count the sides. So this one has 1, 2, 3, 4, 5, 6, 7 sides. We should be able to figure out the sum of the angles by just plugging in 7 for that one. And then what you're going to do is get a protractor and actually measure it all out. So this would be like 90 degrees there, 90 degrees there, I'm sure. This would be 270 degrees from there to there, 270 from there to there. And you'll have to measure this one, and this one. Okay, so I'm going to let you guys actually go ahead and do all of these last shapes on your own. And then we'll check it out in class. So I'm going to end the video there, and I'll see you guys in class.